Good afternoon, everyone. Thank you so much for making it to the Art and Science talks organized in the frame of the Zurich Art Weekend 2021. I have the pleasure this afternoon to welcome on stage Nora Turato, who is an artist, Prisca Liberali, who is a molecular biologist, and Adam Jasper, who will be our moderator. Adam Jasper is an ETH Researcher, regular contributor to Art Forum, and founder and editor of the magazine Pocket from GTA Verlag, together with Freddie Fischli and Niels Olsen. I don't want to lose any time, so I pass on the word straight away to Adam, who will present you Nora and Prisca a little bit. Or no, first Prisca and Nora will present themselves 10 minutes so that you get their background and their interest before engaging into like a very informal exchange between the two, moderated by Adam. Thank you so much for being here, and thank you so much to you for coming.
So, hi, I'm Prisca, and I'll start with some slides also just to show some of the things we are doing in our research and how we will then interface with some of our languages. And I think what we are mainly interested in is what we look at these single cells across biological scale. Our body is made of billions of individual cells, but that together come together to have a body that can think, that can eat, that can respond. And this is what we really are very interested in understanding at how this biological scale, you have proteins, cells, or multicellular system of the full body. And if you imagine all the scales are in a way different, but they all follow similar rules. And these rules are that the different cells need to speak to each other, and other cells need to interpret the language of the other cells. So there's a strong communication that really is important to bridge these scales. And the biggest problem is that these tissues are not engineered. They're not constructed top-down like a machine where you can put it together. Our body is really mainly built bottom-up with, and here you see it, some cells that while they grow, they change, and they have what we call long and short range communication. They always speak with each other. There are some that speak, and there are others that interpret what is happening. And this is very important because this way of building the tissue makes them extremely robust and resilient and resistant. And this is why I think also for the drugs and for our development, it's becoming more and more important to understand this scale of the body. And this is what we do. We take cells from the body, so we take from the liver, from the intestine, from the brain, and we create mini tissues inside in the lab. And so here you can see is one cell from the colon of a patient, and we can recreate fully a small intestine and a small colon in the lab. And this is becoming more and more powerful to go in different aspects of personalized medicine. So we can go and take samples from everybody, and we can then test direct drugs. And for example, in the Netherlands is where they are extremely advanced with this type of and they take from children with cystic fibrosis, and then they take a little sample, and they can then find the best drug for that kid. That is quite important when you have a small children that has a problem. And so with this, and this is the last slide, so this is what we can do now with all the different tissues. We can test drugs. We can also do a lot of different aspects. But the reason I wanted to show it to you, and then I think going back also to Nora and to also some of the things we will be discussing later, is this communication. For many years, we have been looking at also in the pharma to find genes and then drugs that affect one gene to then have the body. But there's something in between that are cells and how they communicate and how they interpret their reality. And to do this now, this system that are called organoids are extremely important, and this is, I think, our discussion on how we communicate and interpret the world at all different biological scales between people and between cells.
Prisca, thank you. Can we go back to can we run through your slides one more time? Because I'm kind of ignorant, so I wanted to just get a little sense of it again. And also, while we're running through them again, can we prepare the next slide deck as well for the main part of the talk? Okay, so if I understand your research correctly, you're not just dealing in the behavior of large molecules. You're dealing with the sort of emergent properties of groups of cells, and that kind of in-between scale between what happens on the level of a single cellular life form and what happens with the mass of an organ or with a body of tissue.
Yeah.
Why is that so difficult to research?
Because it's also technically very hard to follow a process that is very fast on a little cell that has consequence days later on the full tissue side. So even, for example, what we do in the lab, we build microscope to be able to look at this, and there are crossings, to really get from the little particle all the way to the tissue. And conceptually is also hard because, for example, to look at emergent property, you need variability in the system. You need variability at one scale that then breaks its symmetry or has some differences, and this will then bring another property at the higher scale. And this you see, a cell cannot digest. A cell can make a tissue that is an intestine that can digest. So you have property that are really coming only when you are at a higher scale.
And this is maybe the fact that I have the wrong training for this subject. But what I immediately notice is that if I look at these 5 images, that the image of the proteins, that could have been made in the 1990s. The image of the organelles could almost have been made in the 1980s. The cells image could almost have been made in the 1960s. The organs image on the extreme top right could have been made in the 1930s. But the image for the multicellular systems, that's totally strange and somehow completely contemporary. And so as part of what you do, inventing new ways of visualizing phenomena at scales that we don't have conventions for.
And this is what we also, really this principle, what are the rules that are regulating this system, these multicellular systems? And it's really a field that is taking more and more right now to understand how this interaction comes. We have been looking also developmental biology, looking at the full body and at development. There were the cell biologists looking at cell, but there's this biological scale in between that for many years was missing. And so now many different institutes are really trying to tackle, and also conceptually is quite different because you have heterogeneous system and this communication that at the end is how does a cell read its environment. That I think it's... And then this is how we normally try to get and for the science, this scale is getting more and more important. And one of the aspects is also the heterogeneity in this system that are...
But I can also imagine that this is an artist talking, that in like a kind of a really weird, psychological level, the tissue is rather anticlimactic, It's like the other object. It's like not really an organ, not really a cell. Yes. So it's like in a way possibly uninteresting to a lot of people to kind of really fully get into it or fund or get engaged because it's it's just what are you growing,
yes.
So I'm wondering how you deal with that, because there's a reason why we're only now there is because it was uninteresting. It was just like a tissue.
Yeah, and I think it was 2 aspects, and it's absolutely true because on one part is some of more the organismal saying, oh, you just have a piece of tissue. Yeah. It doesn't do anything. And on the other side, the cell biology is just a group of cells. It's just a bit more of what we are doing. And part of it is the uninteresting but really fundamental question are really now coming on how this interaction, and it's helping us because most of the other experiment for human disease is also very hard to do. For example, we are very late in women health because it was impossible. Mouse and model organisms have a reproductive organ that are very different. And now we can create a placenta in vitro. we can create, and this is very important. So I think that now, especially for the human part, it's getting more interesting because we cannot look at the human and perturb it like we were doing it.
And what are the potentials for like transplantative medicine here? Like, is there any kind of, is it something that it would go towards or not?
I think it's going towards it. But will be the last step.
Okay,
now we are really very good in trying to test drugs and to do other things, but getting to the point where we can do it in mouse, it works. But I think, and I think will be also ethically something that will have a lot of discussion and all of it. Because
of course.
in Europe, we are a bit behind. There are other countries that are already testing much more and much further.
Yeah, it's always really interesting with European laws. They're so much more conservative in a way. I mean, even if you look at the copyright laws or privacy laws or any kind of, they're really, really.
And now I don't know. Sorry. But 2 weeks ago, that was a very big change for the law right now. Exactly for that, because for human embryos, you could grow them only 2 weeks, and so it was very hard to study them. And now this change, the 2 weeks, just changed like a month ago. And so this is completely changing the landscape of what we can do as a research to understand fertility, to understand very early human development. So this is very important, and we are still very conservative, and Switzerland is also not. But in general, Europe is very hard. There are countries like the UK that, for example, go a bit faster.
So it's now legal to grow a synthetic embryo
for longer
beyond the 2-week limit.
Yes.
What's the limit now?
How long now?
We are just starting. So it just happened. So now we are trying to see, now is really where the research come in. We arrive at 10 days. We also grow synthetic embryos in the lab, but we arrive to 10 days, something like this. So that will be we will need to develop new technology also to support this in vitro growth and making a placenta that then we put the embryo with the placenta.
Okay, so we began somewhat in media res. For those gathered at the back, if you're uncomfortable standing, please come in. There's plenty of seats at the front if you feel like sitting down. But we began partly with the topic of Prisca Liberali's research, partly because Nora in this context almost needs no introduction, as many of you would have seen her presentation yesterday, and also because Nora Turato works very much with language. And what we thought we would do is hone in on problems of language as a way of, rather than showing two separate presentations, one by a scientist, one by an artist, trying to find a kind of communicative space between the two.
May I just say something before? I'm really excited about this because I've been thinking a lot about occupational tourism in arts, and how, that you have a lot of these topics, like this kind of slide. I can imagine an artist making that kind of slide and not knowing what you do at all. And it's like these terms and all these concepts are tossed so easily on YouTube, but also in the art world. And I'm always so excited to, for instance, if an anthropologist comes to a lecture by an artist talking about anthropology, and it's always somehow, the artists tend to latch onto outdated concepts or things that I just kind of, there's this idea of research that is just completely different, and then that comes down to language also, and how we treat more lightly language, such as saying to publish something or to research something. I mean, research is one big word that I'm super, when I say I research something, that has nothing to do with what research that you think is research,
But I think that even there, the research is for example, that I recursive thinking, that is in a certain topic, you think in a certain way. You do experiment, but there's also some aspects, and so we probably have similar rules on how we do research, and especially innovate in a certain field. How do we create something different? And I think that's sometimes also, I was very excited to have a conversation that is quite in a different space, what we are usually probably having.
So in that vein, we set up a game. Can I put these slides up? The ones that I have on the screen now. Great. This attractive man, C.P. Snow, made a famous radio presentation in 1959 called The Two Cultures, which was about the divide between science and art and the difficulty in having conversations like this. Nice. And since C.P. Snow's essay, there have been endless attempts to solve and revisit and somehow suture over, to use a scientific metaphor, this problem. one of the more entertaining attempts via cybernetics was Stephen Willat's metafilter from 1973, in which he set up a kind of pretend computer. It's essentially an empty wooden box, a kind of console with some laminate on it and a couple of screens with a projector. There's no computer inside of there, of course. But the game that Willat's devised, based on his enthusiasm for cybernetics, was that he would show ambiguous images on a screen. And then the two participants who would not be able to make eye contact would choose a series of words. And once they had agreed enough on words to describe a problem, they would then be given a more complex image. The idea being that through agreement in the use of words, you could solve social problems. I don't think it worked particularly well, but it's a great project.
Do they still do these kind of like studies? You always hear about these studies where they put the two people and then they, but do they do it still?
There's a basement in Princeton.
Or is this like 70s?
Yeah, mostly they don't. But it's, I guess there are variations on this. I mean, I met someone whose entire career was A/B testing passive-aggressive posters designed to encourage people to reduce their energy use. And his entire test field was two elevators. And one of them he'd put poster A, and the other one he'd put poster B. And then he would measure the energy use in that building over the next 24 hours. Then the next day he would swap the posters.
I guess there's so much data just out there today. You don't need to put people to do anything for you. Yeah. Even though I used to work some time ago, before I was an artist, I worked in advertising, and we would work for like a big company. It would be surprisingly a lot of like data coming in about like how people consume, how people move, like focus groups and stuff. And I was always wondering, like, are they for real? Are these things truly that, or is somebody like making that thing up? But like I remember we were doing something for a menu in a plane. So there was this whole study of how people taste differently in an airplane, and it was like it has to be more salty or it has to be like more anyway. But it's just like, so I think it's interesting that these kind of things are moving into advertising world more. It's like less. I don't know how.
Side. So for the experiment like this is more on the social side.
Exactly, it's more like a kind of a thing that would go into.
Yeah. And they're very hard to control.
Facebook would do it.
Now it's also very hard to control because for coming from our hard science point of view, is like what's the
how do you control that? Who's this person? Where does he come from? What did he eat?
Which mood was he in that day? And then we would do it again 10 times. It would be completely different.
But he ate an egg today.
And he ate it also 3 times after. And trying to correlate this with anything.
Yeah, exactly.
And then, and I think that this is what data and big companies that are using data are getting much better than any scientist.
Exactly.
Because they can have tons of them, and then comparing it with your phone, and then also how you looked that day, because you have your phone face recognition that day that can associate with which music you liked and how you interacted with the other person, how long did you speak. All this data in a way are there, and will be insane.
So, based on all of this, then, based on all of these themes floating around, we've constructed a quick game, which now we seem to be already in the middle of. This conversational game is, we've chosen 12 words, or more to the point, we've pulled them, and we're going to try and find out what you think of when you see each of these words. So your first word, should you choose to accept it, is scale.
I think you can start. I already...
Scale.
And if you don't like a word, you can just say pass.
Scale, I don't know, like, is it... My first thing was like a size of a thing or zooming in and out, but then I'm thinking like scale is more like could be also maybe for you more like weighing things, or I don't know.
And measuring.
And measuring. For me, it's more like about like the visual impact or something, or kind of like zooming in and out, or perspective, which has to maybe do more with the visual looking at things. Mm-hmm. And then like maybe yours is more measurement based, or like a metric one. And
metric, and how things are changing just in the place when we are actually objectively able to measure aspects of life. And that's, I think, very important. All fields changed very much when people just started to accurately measure behaviors of cells and people. But it's also the scale of biological scale, I think. For me, it's coming, the cells is one, the multicellular system is another one, but then it's social interaction, people interaction, and they follow similar rules. They communicate, they create clusters of people, they exclude others, you create society, you create religions, you create war. And similarly, this is happening in the body. You create cluster, you create disease, you create immune system reaction, inflammations. All these are type of behavior that almost can be recapitulated in social
Yeah,
level.
but even like metaphorically, you could look at like in terms of like, I don't know, I was thinking this might be very whack idea, but for you especially, but I was thinking in terms of like, you know, cancer and being like a growth thing, and with a society also we are like very concerned with growth, and everything is growing, and in a way that causes inflammation of sorts.
Yes.
And inflammation is, I don't know, I was just thinking about that.
And
in
it's
terms
really, and it's conceptually, I think, quite similar, because we are full of mutation, especially with age.
Yeah, but the more it happens, more it grows, more it mutates in a
more
way.
it mutates, but many people with mutation don't have cancer, but in some type of environment, you can start creating one. So we also don't understand fully where that happens, and in the population is exactly like this. You have growth, and you have cities that have uncontrolled growth, others where it's more controlled, or on the other side, you have the inflammation that is the response of the environment to exactly, and so we are trying to.
I think he's trying to kid us.
Okay, robustness. We get to.
I think the moderator is unhappy.
The scale of the moderator.
We have 12 words to get through. Yeah. I have to keep you on topic. Okay,
Yeah,
robustness.
just like, yeah, please.
Yes.
Govern us.
So what about, so then if we move from scale to, robustness is a strange word. What's the difference between then robustness and resilience? I don't know.
Robustness is more that they don't change. Mm-hmm. Resilience is more that when they change, they go back to where they came from. So it's like a spring, you just can move it. Robust, it moves, but again, it's a question of semantic. You would ask 20 other scientists, they would probably give 20 answers on this. And then, so what is robustness of in a language?
I don't know, like, yeah, if you say robustness and then you look at the resilience, like resilience is Chihuahua and robustness is like an elephant. You know? It's like and then we were also talking about the other day, like you were saying about some theory that the lifetime of an animal there's a theory that it corresponds to the amount of heartbeats, that the faster the heartbeat. Yes. You were saying this yesterday. So and I was talking about how Chihuahuas live really long and how they're really resilient, and so yeah.
Yes, the scaling. Go back at the thing of the animal is quite interesting. Why do you have an elephant that has 11, 12 months, and then there's the size, but everything scales. There's the time and metabolic, the heartbeat also scales. Everything goes, and lifetime also sometimes. But the robustness, I think. But is there something also in your interpretation also on the robustness of a language? Do you think there's some languages that are more robust than other, or is the interpretation on how they evolve?
Well, I mean, I think you can really, like, if you would really look at how languages are, I mean, if you look at English, it's ridiculous. You know, I mean, where I'm from, Croatian language, the Slavic language, we have but it's, you know, you speak how you write how you speak, and it's very, you know, straightforward. But if you look at English language and how that developed and how things are pronounced differently, and it's like spelled differently and pronounced the same, and they really like pull this thing from all over the place, and so yeah, that's kind of, I don't know if that would be robust, but I would like
more resilient.
More resilient, and like maybe language that's where I'm come from, like Serbo-Croatian, that was more robust in a way, because it's like but you know.
And some of the, can I just yes. And some of your performance, do you have languages you do it better, or do you feel more comfortable in playing with, or playing?
Yeah,
or
I feel most comfortable playing with English because it's not my language. Mm-hmm. So I'm having this total like, you know, it's like, I don't think a native speaker could as freely like, you know, fuck with it, because there's this naivety to it that is like, oh my God, that sounds great, you know. so let's change it, and like in your like mother tongue, you have so much baggage and so much assumptions. I mean, you even talk to people and you can like tell where they're from, what class they're from, you know. You make so many assumptions just based on how somebody speaks. I mean, in London, you can like figure out what neighborhood is someone, not what city, but what street they're from only the accent. So it's like, and I don't have that with English. I cannot tell. I mean, I can tell maybe a few things that are most of the people can tell, but not more than that. You know?
What about symmetry?
Symmetry.
Symmetry. Shall we skip this one?
Pass?
Variability.
Yeah, that's better.
Yes.
You with your macho words. Yeah.
I didn't choose them. That's really not
Symmetry.
fair. They chose the
What
words.
is
Moderation.
Wow, this power structure keeps flipping on me.
symmetry? We skip symmetry.
Society. Sorry. Variability.
Variability.
Variability. You go now first. Come on. I mean.
For me, variability and heterogeneity in between everything is something, diversity in general is something that is coming very often both in my work, that comes with the variability between cells, that all of a sudden you need this variability, you need heterogeneity to evolve, you need heterogeneity to be robust, you need heterogeneity to have this diversification. And then I find it an extremely interesting concept that you need variability to create robustness.
Yeah.
And this, you see it in the workspace, on the diversity of teams, you see it in the diversity of society, that you can create it, and while society becomes more equal in the sense of too similar, then things don't go.
Yeah, but same with like if you buy like a really expensive dog from like that's been inbred for like ages, and then of course this dog is getting sick constantly, and then you have a rescue dog, and this dog is just like
mine
completely
lived 19 years. My rescue dog, it was destroyed.
Rescue Chihuahua.
Let's try.
That's variability.
That's variability, and how variability.
I'm just going to use Chihuahua to interpret each word.
We'll try to bring it back in all of them.
I don't know how you can use Chihuahua to interpret synchronization.
That's tough.
Synchronization. It's like synchronization. It's funny because I think they were doing this thing to go back to language. If you like repeat after me something and long enough, you will eventually kind of match me. So that's how, like, when I, for instance, when they teach accents or pronunciations, like there's this kind of thing called shadowing. So you can, like, if you shadow something long enough, you will kind of end up kind of matching it, and it's just what we do. Mm. So if you have it a lot in, like, when you're learning an accent or you're learning like how to speak a different way or something, or to pronounce something correctly. A lot of, like, for instance, actors do is that they shadow the tapes of speakers, and by shadowing enough and kind of matching, synchronizing their frequency, because this is all not only about how you pronounce things, but also how your alignment is. So you're like kind of synchronizing a lot of things to match it, and kind of it's interesting that we just naturally match. This is like kind of some evolutionary instinct.
Prisca, does that have something to do with the mirror neuron?
The
mirror neuron?
Yes, we have mirror neurons, so especially children, when they're born, they just like to mirror you. To teach them how to move their hands, you move your hands enough, and they will start doing exactly this one. Also with my son that is here, you'll see with that what we did. And the other thing is cells do this. They synchronize, because at a certain point you want things to happen all a same place. You have variability, you have robustness, but at a certain point we have, most of us, 10 fingers.
Get in line.
The arms are symmetric, and then they're still quite the same length. And this happens by synchronization. Cells, they have frequencies, and they align with each other, and they can and they copy each other to then do it. And there's a master regulator that's just to set a pace, and many that copy it and follow this, that from the light day type of rhythm that we have, and
yeah, I was thinking also in terms of, like, when we consume as us as consumers, as somebody who buys stuff. Let's say you're going to buy something. We're very precise when we shop. Like, we really have this precise idea of, like, what kind of product we want. We don't want, like, things that are kind of don't get us matched to this thing that. So it's really funny how we keep on, like, you have this variability issue, but, like, kind of fitting in and synchronizing and matching. It's even like a part, even when you want to be different, you are still synchronizing to something. You know, you always have some sort of like a variable that you're attaching yourself to. It's rarely do you just go about.
And this is why, going back to your advertising that you were saying at the beginning, is where advertising is really using this synchronization, because there's where they plug in and saying, okay, let's...
Yeah, exactly. Let me get there. You know, let me match you by buying this.
And you fit in. You know, you see you like this and that. You miss this one because all the other people. And so you try to synchronize all of them. And so it's... research.
Google.
And Google knows it exactly. It's like the advertising that comes and tells you, click here, you can get it with one click.
It's crazy.
But research has been a word that's been heavily bandied around in the fine arts.
In architecture as well.
Yes.
I mean, I think it started, my theory, I think it started more with architects because they kind of lost this kind of power they once had, which was really political. You know, you were kind of, I think there was I mean, maybe 90s were last time that they really got a kick of like, you know, really kind of controlling the environment, how people live and how cities grow and shit. And I think like moment that kind of power waned with like also climate change, you know, today you cannot make Mies van der Rohe pavilion because it's not legal. You know, it doesn't adhere to climate standards. So in a way that became so constricted, much more than art is, even though that we could also talk about. So I think like the research became kind of like a refuge for these people to actually open up and again be free and have some power over the content and over what they produce. So I think it's like a proliferation of research in creative industry has to do with like kind of more constrictions in real, and you know, like more constricted you are, more research you produce in a way.
So do you think that research in the fine arts is also about power, or largely about power?
I mean, I don't know, I research a lot, but I really don't know also what research, I feel really, really weird and really, I really don't like to call what I do research because I really have a feeling, I have a hunch that my research has nothing to do with her research or like that it's, you know, I feel like it's almost like...
So, but then I can ask you, what is your research? You know, it's like
yeah, exactly. I mean, it depends also how you, research. What would be a nice synonym?
And maybe the synonym would be different for me and you.
Yeah, what would be synonym to research?
For us.
Come on, Adam.
This one?
Abstraction. For us, it's also, in a way, partially is abstraction, so to abstract some of the results, but part of it is really to get to the point and experimentally prove some of the concepts that you have. But abstraction is a core part of the thinking process that is trying to abstract some of the information, for example, to another biological scale, in trying to understand. So a lot of abstraction in the abstract thinking, and we call it also recursive thinking. We just go back to the same thought in different ways, in different environments, and then try to go deeper in that thinking process. And then together you put it. But there's also our experimental part that, I don't know, in your case, how it's...
Actually, this method is...
I mean, it's funny because these kind of terms, which are research, abstraction, they are really tossed. I feel like I use them a lot, these terms, and I don't really, really know what I mean when I say it. I mean, I know, but I don't, like, I cannot tell you with, like, full certainty I know what abstraction is, you know? I think that's weird. But, like, okay, last time I used the term abstraction was like a few days ago. I was working with my vocal coach on a sentence or something, how to pronounce it and how to like say it, and I often say, okay, let's make it abstract by these are, you know, so by kind of really kind of slowing down and really getting into phonetics of it and then looping it and kind of trying to, you know, sample it, and through sampling it finding like a tone that is right for it or something. But I mean, yeah, is that abstraction? I don't know.
I have this, last time I used it was with one of my students, and I was trying to, but you need to abstract your thinking, you know, you're in these two little details, trying to take a breath. And I gave them the example, there's this movie that's called Inside Out. It's for children, and they go into the abstraction room. And so they are in 3D, they move, and then they become very simple, then they become in 2D, then they become a line, and then they become a point.
Yeah,
And,
but so basically it's more zooming out, and for me
yeah.
it was more zooming in, which
Yeah.
is weird.
But
Publication. Feedback.
Yeah, we skip publication feedback.
We can go back to publication.
No,
if you like.
feedback is great. Feedback. Response? I don't know. I don't think. I don't think. I mean, yeah. I don't think you get so much feedback in where we do. I think there's more feedback in your world than in ours.
Yes, but the feedback is anonymous feedback. So we send in a publication,
Yeah.
and then we get 4 letters from 4 scientists, not signed, where they're actually telling you what they think about your work. But also there, it's
Yeah, but also feedback can be also in terms of like how cells can. Like
yes,
there's also
on the
probably feedback.
Yes, there, for example, on the cells, there's a lot of, for example, mechanical feedbacks on the tissue and back. So
Yeah.
that we have a lot. But again, this is an aspect that's very hard to study because you need really to cross the scale. You need to understand how a bigger one feeds back on the individual cells. And this is technically still extremely hard. And even there, conceptually, and in an abstract way, like, actually, why do we need it? Why do you need this feedback? You need it for synchronization, for coordination, and I think that's. But yeah, for language, you don't have on the feedback. You don't have a lot of feedback. You don't. Yeah.
I mean, feedback, like pushing. I mean, that's also I was thinking about how, like on the internet, the language you use. I went to art school in Amsterdam, and there's this English that we use there, which is like completely crooked, bad English, but everybody kind of agreed that this is the right English. Sorry. So I was always thinking about how, in certain environments, so what's going to happen with language in the long run with like, YouTubers and all this things.
Scientists, we are the same.
Scientists also, there's all this like kind of mumbo-jumbo language thing that kind of slowly becomes the real thing through feedback of like, oh yeah, I like how that sounds. Let me start using it also. And
other people start using it, and then you have these spikes of use words or and then.
And my favorite thing is like this new feature on Google where you can see like how the word okay, I should stop. I don't know. Anyway,
that is a physical instance of feedback. I think.
Yeah.
Technically,
no, I think it's just me like bumping into.
We had one word we snuck in at the end, which.
Evil.
Evil.
Yeah.
Which was the word where we thought there might be the greatest divergence of opinion or position.
Why? Yes, your microphone. On the evil part. With that. Evil.
What constitutes evil in the fine arts versus evil in the biological sciences?
I don't believe in evil. I think people are mostly just dumb. Or I know. I really don't. I don't think anybody's really evil. I don't. I think often it comes out of some ignorance or dumbness, but I don't think anybody really goes out and like maybe evil.
Yeah.
So I don't think evil exists.
Cells might.
Sorry?
Individual cells, cancer cells might be evil.
Yeah, no,
but
I don't think they're evil. They're just like, oh my God, let me procreate, let me make more of myself, I'm great, And then it's cancer, it's like, and then we interpret this cancer as bad, and this poor cancer cell is just like, let me do my job.
Yeah, so that's it's fun. I agree. For sure, with people, I fully agree. There's no evil. And probably the same behavior in different environment would be considered perfectly fine.
Yeah.
So it's also in the environment you see that that behavior is also, I think, evil or not, or how you can stigmatize it, or you just define it.
Yeah. And evil is more kind of an interpretation
yes.
of something. So you interpret something as evil, as
And so what else is really interpretable more than a real part? If it's not evil, so also nice. So a person is nice, it would also be
when I say something is evil, or when I think something is evil, I'm really interested in like finding where it comes from, because it's not evil. Evil is not like the source, It's like there's complete other sets of motifs and reasons that generate something that I interpret as evil, But I doubt that things I interpret as evil are meant to be evil.
And so maybe also a cancer cell is evil only because interpreted differently from the rest of the...
But it's actually just a cell, like any other cell.
And then and then the immune system interprets it in an evil way, or who knows? Is it in the interpretation of the?
Yeah, no. So I mean, there is, like, for instance, like in cancer, you have malicious cell, or like a cancer cell. You have benign one.
Yeah.
That's so benign is opposite to evil, or.
Yes, it still overgrows. It still probably have mutation.
Yeah, but it's not evil.
But it's not evil, and it doesn't create. And when does it change in the different one?
Now,
sorry, I'm just.
We've lost our most important audience member. That means that we should wrap up in the next seconds. So that was 12. I mean, 8 words between art and science. Thank you very much for joining us for this afternoon ramble through the dictionary, and we'll be back next year with 12 different words. Okay, thank you.